Hello, everybody, and welcome to Handmade Hero, show where we code a complete game live on stream. Before I get started today, just wanted to let you all know, if you didn't see it already because I tweeted about it, we at Molly Rocket here are doing Kickstarter for printing our comic, which we're pretty excited about. We had been pretty excited actually because our comic was accepted for VanCaf 2020, which is the Vancouver Comic Arts Festival, which is, just it's a drive away from here, right? We can just drive up I-5 to it, and we had gotten it done in time, and we're gonna print it, and we were pretty psyched about this because obviously if you do a comic, your end goal is to have a print edition. That's what everyone wants for any kind of comic or graphic novel, right? But then, of course, all conventions have been canceled from now until the foreseeable future. I'm sure. I don't think there's probably going to be a comics convention for many months, possibly even a year. I don't know. I mean, I don't know when it would be considered safe to have something like a convention, which is kind of like the optimal case for virus transmission. People get sick at conferences even when there isn't a new virus going around. There's often things like Pax flu and these sorts of things that people talk about. So we don't actually know when that's going to happen again. So we decided we still really wanted to print the thing. So we made a Kickstarter for our comic that you can take a look at if you're interested. If you like comics and you like space or cats in space, please check it out. We have the banner on the top of the Handmade Hero page. So either of those pages that you might go to on handmadehero.org, it's got it up there. And you could just click on the banner and it takes you over here. It's got a little animated trailer that you can see here that's pretty fun. And you can read all about, what the comic's like. It's an all ages comic. It's good for everybody. And also, if you have kids who like comics, or if you like reading comics with your kids, it's okay for that too. Like, it's nothing gritty is going to happen in it. It's just a fun comic that's It gets a little serious at times. It's got some stuff in it. I don't want to give any spoiler warnings, but it's not just lighthearted fluff. So, it is something that's got some teeth to it as it goes, but again, it's totally G-rated comic, and it's we think pretty interesting. So there's 2 books. Book 1 is done, and that's what the Kickstarter is for. We're starting work on book 2 now. Hopefully you like it. You can check out the Kickstarter and the trailer for more information. There you go. That'll be running for 30 days, and you can check on the progress of the Kickstarter as we go. We also have a bunch of fun stuff that we planned for this month, because if we're doing a Kickstarter, we wanted some promotional things to do, and we wanted those things to be fun for everybody. So also on the Molly Rocket YouTube here that does all the Handmade Hero stuff, we are going to be posting a bunch of stuff. Now, we already had some things on here like Anna Draws It that you've seen before that are kind of fun, that are art-based. And we're going to be posting a bunch more stuff like that. So today we're going to be posting a time-lapse of Anna drawing Meow, the main character, that you can check out. Tomorrow we're planning to post a new series we have that it's kind of a comedy thing. That's an art comedy thing. So if you want to, just stay tuned to the Molly Rocket channel. You can subscribe to it, or I think you can just literally type youtube.com/cmollyrocket. I think that works. Yeah. So if you can remember that, you can always go check back there. We hope to have videos all month long of fun stuff for people to check out related to the Kickstarter. So that's coming too, and hopefully everyone enjoys that. All right. That is it for business. Let's take a look at the non-business side of things. Let me subst our drive and get started here. So we left off last weekend. We lost one programming session to the fact that I was pretty grumpy about some stuff getting said on Twitter, as usual. So let's just ignore that. That's what happens sometimes. And let's go ahead and open up Handmade Hero and take a look at where we were at. So we had a lighting profiler that we made because we need to start optimizing this. We didn't really finish debugging it, and we didn't really finish doing some verification for it. We had a bug in here that some people noticed. This was supposed to be that, and it's amusing that it didn't crash, but probably because the boxes were not read properly. I don't actually, to be completely honest, I'm not sure how that was working. You'd think that would have crashed. We must have just gotten lucky, and the way that the things were allocated, we didn't crash, but there's a couple bugs in here. So there's a few things we want to do. One of them we already fixed, which is that we weren't using the ray sampling here. But anyway, the point is we need to go through this and make sure that we're actually getting reasonable results out of it now. And we may want to actually make a little thing that sort of pseudo-verifies those results. And what I mean by verifies those results, obviously we don't really have a way to unit test in a rigorous sense of the word a ray tracer without some reference ray tracer. So it's not like we really can say for sure that a ray tracer is producing accurate ray tracing results necessarily. But what we can do, for example, is we can at least lock our results to a known case. So we're starting with this raycaster and we want to optimize it. Well, how do we optimize it? We're going to make a series of changes to it and see if they improve our performance based on the profiling information that we have, right? Well, when we're doing that, it's really easy for us to introduce bugs into the system and not know. And we kind of don't want that because we want to know that our raycaster is still working. Otherwise, we might go down routes of optimization thinking that we're getting faster. But really what we did is introduce a bug. And the reason it's getting faster is because we broke it, right? So what we probably want to do here is capture the results of our ray tracer into a log buffer somehow so that we know that they're actually what we actually got out of it. And then at the end we can say, oh, did we actually get the same results that we think we should have gotten for the ray tracer, right? So we kind of need to do all this stuff this weekend to get us in a place where we can actually start doing it. So we want to do that, and we want to actually get VTune capturing profile numbers for us. So we want VTune to tell us what our performance counter is. And we didn't actually get that far in that. We weren't actually able to do that interface-wise. This is why I say I normally use what's a thing called perf on Linux, which is just a way of running an application and getting the performance numbers out of it. That's what I normally do. Let me just run this really quickly and see what we've got here. I just want to make sure that we're still running this application properly. So anyway, the problem that we have, and you'll notice it's taking a lot longer to run now, which is actually good, because before I think we were just totally buggy before, whereas now we're actually getting a real runtime of the thing. So I think that's actually also good too. But anyway, ignore all of that. Let me go ahead and drop this down to something more like 64 here. So we want to do that verification, but the other thing we want to do, and we can take a look at this today as well. In fact, we can take a look at this first because it's something that I need to find out how to do. I'm not used to using VTune to get my performance profile results. So that's a little bit of an issue because I don't actually know how to make VTune do what it is that I want it to do, which is not to give me some weird Intel speak discussion of my performance. I don't care about that. What I want to see is performance information that I care about. And it's a little bit harder to do that than I would expect. So if you go over here, and we run VTune amplifier, right? What we did the other day is we said okay, we've got this HH Lightprof thing. We got it running here. And I don't know my way around this interface very well. You can go into this thing here and we can pick a couple different things. So microarchitecture and memory access are the two things we care about. Parallelism we don't because we're already running fully parallel and with no inter-thread communication. So we know that our parallelism is fine in the game, and that's not our issue. Or rather, if we do need to check it, it's going to be something in the game code, not the Lightning code that's the problem, because there's no locking in the Lightning code. So we don't need to check that in our test app. We don't care about the hotspot analysis because that's not really the kind of performance analysis we're doing here. What we want is these sorts of things. I just don't know, when we look at something here, this custom analysis, I don't know how to even get something in here, right? I want to be able to do that, right? I want some way of doing that. I just don't know how to get YouTube to do that, right? So the question is, how do we get it to do one of those custom analysis things? I don't have any idea, right? I just don't know. Is it hiding behind there? Let me just, no. So what I want to be able to do is something give me a microarchitecture exploration and let me set these, right? Let me set these here. but it's grayed out, right? So, how do we set it? So in perf, what you do is you just, on the command line, you say, these are the things I want to look for. That's what I was wondering, how we do. I don't know, is there something in here I can set? And this is why V2 always throws me for a loop. I never know how to get it to do just the things it's supposed to do. I don't know. You look in here, I can't see anything. Like, I don't see anything about that, right? It's just, I don't see any check boxes. In here, there's no check boxes, right? What if I set it to summary? Nothing there, right? So I just don't know. I don't know how to get this thing to do what it's supposed to do. I have no idea. We're probably just going to have to read the manual, right? I mean, presumably, you wouldn't have all this stuff here if you couldn't make it go. Now, one thing I'm not sure about is whether or not the driver and this talk to each other properly. So, one thing that... Ooh, does this have anything in it? So, no. So, one thing that I don't know is, is it just not... Does it not have, the right permissions, So, for example, in here, when we go to vtune, do I have to, try to run it with extended permissions, which I could do? That didn't seem to work. Try it again. There it is. Run as administrator. So I don't know, maybe the thing doesn't have proper permissions. That seems like a far-fetched thing because it installed its own driver, so the driver should be able to do whatever it wants. Probably. I mean, I guess I don't really know. But so if we run it as administrator, I'm just curious, can I get access to those things or something? No. So I don't know. I just don't know. Let's go ahead and see if we can get some documentation on this, because I just really want it to do the same thing I would do on Linux with perf. And this is why I don't use vtune, is because I always find I just don't know what I'm doing. I feel like this should be simple. You just check a few boxes, but it doesn't look like that's really possible. So let me click on this documentation button. Let's see if we can find anything. All I really want to know is how do I get those performance counters, right? That's all I want to know. I don't really need any of this. I just need some docs that say how to make this thing go, right? This is the profiler itself, not the documentation for it, right? Contents. Analyze performance. Custom analysis. Can I get this? It's actually that was actually what I wanted, was right there. So this is the thing I want is come here. Oh, no, it was here. This is the thing I want. I think. Maybe? I'm not sure. Not sure what they're going to call these. Yeah. This is what I want. Well, I don't really care about precise events. Could be this. Yeah, there we go. Yeah, that's what I want. I want PMC. Yeah. Install the sampling driver, which I assume we did because we ran their installer. Maybe we didn't do that, but it wouldn't be able to. When we ran a microarchitecture analysis before, it seemed to think it was getting those values, so I assume that it did. This worries me. It seems like they think this is obvious, and I guess I'm just thick about how Intel designed this interface. Like, shouldn't it just have a section called, like, how to set up a custom... I mean, am I missing it? Maybe analysis types? Would it say there? I just need someone, just tell me. Tell me how to ungrade the thing. Why won't you tell me? That's all I want. Is that so wrong? I don't know. I guess it is. Is it in here? Okay, all right. Here it is. We've got a clue. Create a new custom analysis type based on available predefined analysis configurations. So we need to use these things here. Okay. So you see we're learning. Maybe I can make this do what I want. So if I go to microarchitecture exploration, and then I click this, maybe. Oh yeah, boys. Look at this. Now we're talking. All right, so let's name this, fruit salad X12 or something. Right. Oh, where'd it go? There it is. So fruit salad X12 for now. And in theory now, I should be able to actually tell it what to create. All the fruit in one delicious salad. So now we should be able to play around with this, hopefully, and get actual, information here. I don't know what that exactly means, but I'm assuming that just allows us to get the PMC from our app. I hope. I mean, I don't know. The CPU sampling interval in milliseconds here, these, I don't think these counters wrap, do they? So I don't know that the sampling interval needs to be that high, or I should say low. 1 millisecond is waking our app up way too often. I just want the totals, right? I don't care about any of this stuff. If you look at Jesus. Okay, so if you look at this, there's a lot of stuff checked. And so, okay, a couple things here. So a little word of advice here, just from if you've never used these kind of tools before. So performance counters on x64 are things that you effectively arm. Like you say, these are the performance counters I want to record, and then the CPU basically has little counters, and every time one of those events that you armed occurs, it will increment the counter. But the problem is there's not that many counters. I don't remember how many there are, if it's 8 or 5, 4, maybe it's 4. I think it's 4. I don't remember, I'm sorry. It only has a certain number of counters, which we can go look up how many there are, but let's say it's 4. What that means is that when you see something like this, and this is, even if there are 8, look at how many there's so many things checked here, right? Each of these events. It cannot actually count those events for you because there's too many of them. So what it actually does is it randomly or systematically, depending on the app, I don't know how this one works exactly, it will just pick 4 to count, arm those, wait a millisecond, which is what this is, wake back up, change which 4 it's counting, and go back for another millisecond, right? So what it does is it goes, well, if you're in a tight loop, I'll just time 4 of them, then time another 4 of them, then time another 4 of them, then time another 4 of them, right? But as it's doing that, it means the more things you've checked, the less accurate any individual one of them is because you were checking it for less time, right? Now, maybe they're uniform across the whole run of your application, in which case it doesn't matter. But if they vary at all, the more things you check, the less accurate they'll be over the same amount of sampling time. Does that make sense? So when we take a look at all of these things, we probably don't want even remotely all of these checked at once because we have a completely repeatable workload, right? So all we're doing is making it worse for us because we're basically introducing a bunch of noise into our thing. We could just do something else, which is like, look, man, don't wake up hardly never, please, at least. I don't care about any of this stuff, right? Don't do that. And I don't know what the Encore, I don't think we're timing anything on the Encore, are we? I don't know that we care about Encore in this at all. The Encore is a thing that's off to the side of the CPU that handles other stuff, right? It's not, I don't think it's implicated in our performance here. So we can crank these up, I would argue, and then just reduce these down, right? Like just get these out of here. And so I think what we can do is just, I don't know how to clear these exactly. Do I manually have to do this? Like, I kind of want to I just want them to all be off, right? Are you kidding me right now? Am I really going to have to go through these and check them all myself? Is that really what's happening? Is that what's going on here? That seems what's going on. I also don't quite understand why are these listed so many times? I'm a little weirded out by that. Does anyone know? Maybe, I mean, if you could explain this to the folks at home, because I don't actually know. I can't explain that. I don't know why. I don't know what's going on there, right? So that's a little confusing. So I'm gonna try just clocking down here, right? And I mean, am I missing something? I mean, I'm missing something, right? Please tell me there was a way to clear these that isn't what I'm doing. I didn't see it, but like clear all. There was no clear all. That wasn't on the table, I guess. I mean, what is happening here? But as far as I can tell, you got to do this. Yeah. Does anyone know? Is this really the fastest way to do what I'm doing? I mean, I know everyone at home really wanted to watch me sit around for 15 minutes scrolling up a very long window, unchecking a bunch of things that I don't want it to count. But, you know, so, you know, I'll still do it for your entertainment, folks, believe me. But I don't actually know. There we go. All right. So when we look at this now, in theory, you know, if I save this thing, and you know what I'm going to do? I'm going to call this not fruit salad. I'm going to call this no counters template because I ain't doing that again. All right. Okay, so what's this button do? Save. All right. So I'm assuming if I want to, I can copy this template by saying, okay, like this clone button here, like copy it. And then I can say, like, I've got two of them. Yeah. Okay. So here I'll be like, you know, the ultimate fruit salad. Every fruit you ever wanted, all diced up into one delicious salad. And then on here, I should now have a completely clean, I hope, slate of these things. Yes. Okay. So now what we can do, in theory anyway, is start to add things in here that will tell us what we're actually, what's actually happening at a hardware level, right? So if we want to, for example, we should be able to select like how many UOPs were actually executed in this thing. So I assume something like this, right? So you can see here, like, I mean, this right here alone would be the complete analysis for just like the throughput, like the, how many we're doing. But we could say, look, if we're targeting like, trying to get 3 UOPs through or 4 UOPs through, something like this would be, sort of what we want, right? This would tell us how many total UOPs were executed. In fact, you know what? We could just do this and say, here's how many cycles none were. Here's how many cycles like 1, 2, and 3 were. And that alone would just tell us something about our stalls, right? So let's suppose we just ran that. I assume we can now get some actual information. I don't actually know, but we'll try it. Again, vTune, not my specialty. Okay. So now this is a lot easier for me. I don't know if it's easier for you, but like this is the same information you can get out of perf. So I'm glad we did this because this will actually help me make sense of what we're seeing. And the reason I say that is just because, look, I don't know really anything about how vTune works, and I'm used to using perf, which is just a thing which literally gives you this. So you list the things you want, like here, and then when you're done, you look at how many each event triggered, and that gives you some information about your execution, right? So what you can see here is if we look at how our performance is at the moment, again, if I'm not very much in error, and anyone out there who's a vTune expert, please do correct me on the chat if I'm wrong. But if you look at what we're looking at in terms of hardware events here, what you can see here is it looks like it added CPU clock unhalted ref TSC automatically for us. I assume I didn't check that, right? Because I don't remember checking that one, I don't think. So if we go back and look at the analysis configuration, you can see I didn't check that. So it looks like no matter what we do, it's going to put that in there. And that's fine because that's basically just the thing that tells us, look, how many clocks happened, right? Like how many clocks happened on this core while we were doing our check, right? So that's fine. It's a good reference number for us. Then in here, you can basically see how did we do. So if you remember correctly from back in Handmade, we talked about this originally. An x64 core from the Intel side, so which is what we're on right now. You can see right here, it's a Kaby Lake processor. It basically looks like a front end and a back end. The front end is decoding instructions, feeding them to the back end. The scheduler on the back end has ports it can issue instructions to. Each port can handle certain types of instructions. At any given time, the CPU is only capable of issuing 4 instructions on a cycle. So it will decode and issue into the scheduler up to 4 instructions on any cycle. It cannot ever issue more. So that doesn't mean that you couldn't issue more than, I keep saying instructions, I don't mean them, I mean micro-ops. So actual things the CPU can do. There are ways you could get more than 4 instructions potentially executing apparently if those instructions don't actually really exist, if they're fake in some way. So there's, for example, ways that they can get fused together and things so you can appear to be executing more than 4 instructions. But in terms of actual work, so doing a multiply, that's what's called a micro-op or UOP. You can see it here, right? And if you're doing a micro-op is something that actually can only happen 4 times a cycle. There's only 4 micro-ops can actually get issued per cycle, basically, right? And again, there's something called micro-op fusion, which means that technically, actually, some things that do normally count as micro-ops can get squozed together. So, for example, you can actually sometimes have micro-ops where you actually get 5 in a cycle. We're not going to go into that. But point being, when you're actually talking about things like multiplies, you're never going to get more than 4 per cycle. And in fact, you can't actually get 4 per cycle because there aren't 4 multipliers on the chip. So what you end up looking at is how many ports can issue the thing that you're trying to do, like a multiplier or divide, and how often are you actually issuing things to those ports. That's going to give you your actual throughput analysis. And when you look at what we've got here, what you can see is, at least to my initial estimation, right? What we can see is our utilization is not actually very bad. It's actually between 2 and 3 is where we pretty much live. We're never really stalling out for that much. So if you look at how our throughput analysis looks already, we're actually not that bad. Now, we can extend this a little bit further. Since now I know CPU clock unhalted was the thing that was actually happening, that they're going to add always. Let's just do 1, 2, 3, and 4, right? So in here, oh boy, how do I? Okay. So now we kind of know what this is going to be. I can actually name it. Oops. It doesn't have to be named Ultimate Fruit Salad. Why do I keep clicking that? That's what I want. All right. This is going to be instructions per clock. Simple performance gather of IPC, right? And so all we're going to do here is we're going to say, look, UOPS executed. We're going to go ahead and say that, I think. So we've got 1, 2, 3, and 4. That should be savable. Yeah, okay. So now if I do this, I should basically just have a way of gathering what our instruction per clock tends to be, right? So how many instructions are we actually able to issue on every clock? And what you can see here is that we get 1 fairly often, pretty much all the time. So we're not really stalling out the core completely, hardly ever. We get 2 actually quite a bit, so not very often do we fall down. 3 is getting lower. We're only like 75% of the time hitting 3, right? And in terms of 4, well, that's only like half the time, right? That's not bad. So looking at this, what that sort of tells me without too much further exploration, right, is I don't think right now our primary problem is that our loop is set up poorly or something, right? It doesn't look like we're spending a ton of time recovering from branch mispredicts or, going to the cache, out to the L3 or main memory or something. It doesn't look like we're having a lot of stalls. It looks like we are issuing at least 2, often 3, and sometimes half the time 4 instructions per clock, which isn't bad. Now, it might not be good enough. We could still do better than that probably if we actually go in there and start to think about these loops. But what that suggests to me, if I'm not mistaken, and again, please take it with a grain of salt because I'm not a vTune person. I don't actually know if I ran this perf correctly. I'm just not a vTune person. I'm getting to be a better vTune person right now on stream. This is my vTune education here. But if that actually collected the performance counters that I think it did, and the performance counters that are actually labeled properly as to what I think they are, then this tells me that our first thing to look at is not going to be try to get the data into this routine more efficiently, right? Because it looks like we're processing our data pretty efficiently. It looks like what we're not doing is trimming the ops. So we're flooding, we're putting too many operations into this core. So what we want to try to look at now is ways of reducing the workload, not getting the workload in more efficiently. Because those are 2 things that could, the 2 things we can look at are get the work in more efficiently and do the work more efficiently. And the do the work more efficiently seems more strongly implicated at this point. That just doesn't look like there's a huge amount of fat in there to trim on the throughput. It looks like there's a problem with our algorithm. Our algorithm is doing too much work. So how do we cut that work down, right? All right, so that's the basic idea here. And in order to get a slightly different picture of that, what I'm going to try to do now, and again, caveat, not a great VTune guy, going to go ahead and try now to get it to give me another piece of information, which is what I would typically look for next, which is who's getting throttled, okay? So if we go ahead and... I never remember how to do this. Okay. If we go ahead and clone this again, right? So or actually, you know what? I made one for cloning. Is it this button? Yeah. So if I go back to our node counters template, clone that one, and I go in here and say, change this to port usage. And this is going to be, and you know what? I'm gonna specifically say arithmetic port usage. Checking to see how overloaded we are, or checking to see which ports are stalling, right? So you saw me try, using my limited VTune skills, to have it tell me what the performance counters were on the CPU for which types of cycle dispatches we were getting. No UOPs, 1 UOP, 2 UOP, 3 UOP, and 4 UOP, right? So we were trying to figure out how many micro-ops we were issuing. And what we saw is that we're doing a pretty good job issuing UOPs. But I'd like to know now when we're not issuing 4 and when we're not issuing 3, because 1 and 2 were fairly likely. When we're not issuing 3 and 4, just double check which ports are stalling, right? So who's the port that's overloaded, okay? Now, if we look in this list, right, what you can see here is we can actually find out for each individual port, 0, 1, 2, 3, 4, 5, 6, and 7, we can actually see which ports are getting these UOPs dispatched, right? Now, if I check them all, which is the information we actually want, the problem is that on that run, we won't actually know which one is actually happening, right? So if you look at what that information would give us, because when we're running it, that's too many, right? It's too many for our perf counters. Now, it may be that it's fine because, again, this loop is a tight loop, so it doesn't really matter. So I'm going to try and see if VTune's alternating which ones we're checking works there. But if it doesn't, we can actually do what this is actually called, which is arithmetic port usage, and get rid of the ports that are actually not implicated in our algorithm much. So, and just to give you a perspective on that, as you people who watch the show frequently know, we have this bookmarked. It's the x64 UOP table. And if we want to, we can look to see, for example, the types of things that we're doing. So, for example, we know that we need to do things like shuffle. How do I make, where is that? There it is. So we know that we have things like shuffle. You can see the port analysis here. It's on port 5. Now, again, I'll just restate this. You know this. I've said this a bunch of times, but. So when you take a look at the uops.info, this is telling you for each particular thing that you might be doing on your processor, this is telling you what the actual port is that will be necessary for the ALU to complete the instruction. So if you take a look at something like a pshuff, which we know we're doing for broadcasts and stuff like that, what you can see here is there's different ways in which that instruction may have to execute, and that's what's listed here. So pshuff in this case, like a pshuff D, a pshuff HW, pshuff LW, you can see that XMM lines, the ones that just have XMM, they tell you what the port usage of that instruction is. So it says 1 UOP on port 5 is the only way, right? That means that's what happens. When you have to do a pshuff, it will execute on port 5, period. If port 5 is blocked, so on that cycle you shoved something into port 5 already, that's it. You cannot put another instruction into that pipe. So that will block port 5 or wait on port 5, period, right? So what are these other things? Well, anytime you see memory in there, so you see that I is immediate, by the way, so that's just telling what kind of shuffle to do, right? So an XMM is the register. M128 is saying that it's got a memory operand, right? And Intel x64 is not a RISC architecture. It's a CISC architecture. So it allows you to do things like, say, in this one instruction, load something and operate on it in the instruction, bypassing registers altogether. That's something it can do. So this instruction is a bypass register instruction. It says, I want you to do a pshuff on this register using this piece of memory, right? Right here. And that instruction itself means that not only does it do the pshuff, which is represented here, you see it's the same 1 UOP on port 5, it will also tie up the memory ports, right? So what does this mean? Well, the memory ports are port 2 and 3. They're the things that can actually do loads. And when you see 1 times P23, what that means is that it's going to issue 1 UOP on port 2 or 3. So that means it has 2 chances to get it right. If port 2 is blocked, it can issue on port 3. If port 3 is blocked, it can issue on port 2. So that means we can actually issue 2 of these per cycle. Now, we couldn't issue 2 of these per cycle because they require port 5 and only 1 port 5 exists. If this was P15, for example, we could issue 2 total pshuff instructions, but since it only has that one, the pshuff will block on the port 5. But if something else was tying up port 2, no problem. Port 3, it could use, right? So we care about the arithmetic ports. And what are the arithmetic ports? Well, as you can see, port 5 is one we may care about because it's going to move our data around. Not technically arithmetic, but we need it for arithmetic. We have things like a padd, right? An instruction that's going to do a padd that's adding things together, for example. What's the actual scalar add, though? What's the... It's PS or whatever. Is that add PS? That's it. I don't remember the mnemonics as well as I should. I don't do enough assembly language programming. I wish I did. So if we're doing something like an add, right, what you can see is the typical layout of these things is it's going to be used on ports like 0 and 1, right? So port 0 and 1 do the heavy lifting of arithmetic usually. You can look at the mul PS. You can see it's the same, right? So if I multiply, I'm in there. Now there's a div PS, and that you can see is on port 0, right? So you've got a lot of different things going on there that we care about, but they're all like 0, 1, and 5. That's where we're going to be hitting for our arithmetic. So if we wanted to, we could just do this and say, look, here's our like floating point arithmetic stuff that we're gathering. So I'm just going to call this like our like float port usage, let's say, checking to see which, what is happening? No, don't change. Okay, there we go. I don't know how to use VTIM. I said that already. Checking to see which floating, or this is analysis of floating point port usage and related ports, right? So if we want to, we can go ahead and say, let's take a look at that specifically. Tell us how our floating point port usage is, and now we've got a way to collect the information about that. So if I run this one now, in theory, we should be able to see a little bit more information about how our floating point ports are doing, right? So what's happening there? All right. So again, if we look at this particular piece of information and we see like what the port breakdown is, I'll be honest, if we look at that, that doesn't look fabulous. Is that what I think it is? Can I get a... Can I get a... I can't, can I? Let me just grab this guy again. That's cycles per thread when UUPs are executed in port 5, and cycles per thread when UUPs are executed in port 1, cycles per thread when UUPs are in port 0, right? So, looking at that, it's a little bit confusing. I'm not sure how to interpret that information. So let me make sure I'm not just confused. But here's what that seems to be saying, right? And this is good. If this is the case, it's good we did this because we're learning something. So what we said is 8.6 plus 8.6. I'm just adding up these numbers. Plus 7.6 is 24.8 out of 18. So that to me says, like, all right, the number of times, so if I subtract 18 from that, the number of times we issued 3 UOPs should be around 7. Is that what we saw? Let's try and get this going. There we go. And see, it's not. So, okay, so this is good. This is information we needed. So that suggests to me that these, when we're looking at what UUPs are executed here, maybe we're actually shoving things into the memory port a lot more or something. So I want to keep going on this a little bit here. So let's actually ask this question. Let's do another one of these. Where I just say, okay, you know, clone this one, I guess. Let's call this all ports usage. General collection of all execution ports at once. And we're just going to say, look, all right, I clearly need a little more information before I can decide what's actually happening here. Oops, I should just search instead of scrolling. UOPS dispatched. Let's just go ahead and say, give me everything. Just to see how good that does. If that is able to actually give us reasonable information, then we can go with it, right? So click that, right? And then I run this thing, hopefully. I don't know if this is gonna work. I'm just trying. All right. So if we take a look at what's going on here, what you could kind of see is we've got the port usage breakdown, and a lot of the stuff that we're issuing to is on port 2, which means we're doing a lot of loads there. 2 and 3 are our loads. So again, you can hopefully see why I wanted to do this. What that tells me is that if we look at the total number of hardware events that we were talking about here, which is 17.8, if we add port 2 and port 3 together, right, that's actually like this number, right? So we're loading a lot, right? These two issue together, so that's not really a fair comparison. There might be a thing where that's like which cycles have something issued on either port 2 or 3, which would be a better way to read that potentially. But what you can see here is, yeah, our port 6 and 7, not super interesting. 5, somewhat interesting. 3 and 4, which are write ports. 4 and 5 are the write ports. Is that right? No. Just 4 is the write port? I forget. Because 5 is the permutation port, so it's not that. What's the write port? Please tell me. Mauve. I just need a mauve PS. I don't know how to search for that. Let's see. Mauve APS, that's what it is. Or UPS in this case. There it is. So this is the load, which we know. This is the store. So it looks like it can do 2 or 3 or 7, actually, but requires port 4. So I guess what you would say is probably doesn't much matter because port 7 is available for that anyway. So it's really just port 4 is the write port. So this is what we're looking at for writes here. You know what I'm saying? And it's pretty interesting that those are completely balanced, but you know, that's where we're at. So yeah, there we go. That's the port breakdown as we see it. It looks roughly like what I want, but not quite there yet. So I would like to see a lot more 015 issue, right, than we're seeing. So I actually do think, based on this breakdown, now that we're looking at it, it does look like we could be a lot more efficient with the memory, okay? Because I'd like to see us issuing 0 and 1 a lot more than we are. And now I don't know that that's because the memory isn't coming through as fast as I want, but it does look like we're issuing a lot of instructions to do loads, and I'm wondering if we can get that down, right? So I don't know. I don't know, right? I'm just guessing. But you can see why, now that I, hopefully, again, caveat, if vTune is doing what I think it's doing. Perf on Linux does this, and it's doing what I think it's doing. This I don't know if it is or isn't, so I just don't know. For example, I don't understand why, if you're only checking for like 4 things, why this is only 2 and that's 60. I don't know. That doesn't. I don't know why these wouldn't all be the same. Like I just don't know what it's doing. But anyway, doesn't really matter. Point being, like in one where we only do a few. Like here, those should all be the same, shouldn't they? Because I'm only asking for 4 counters. I know it can do 4. So I don't know what that means. Hardware event sample count. I just don't know. So I don't know what that means because I think these should all just be the same, right? These should all be the same number, I would think. But apparently they're not. And so I don't know what it's trying to tell me here, but it makes me a little nervous. Like I said, not a vTune guy, don't know. So anyway, if we actually want to now take a look at what's going on, that does suggest to me I would like to see how these numbers change if I start to compact the memory usage a little bit of this thing. Now, before we do any more of this, I think I've done what I want, which is I now have a way to take the performance analysis, hopefully get the performance analysis numbers that I'm looking for. So before I go any further, I want to validate that our actual code is working right, because these may be bogus numbers. It may be that that I've got bugs in the test harness that are making it so we're not really testing. It's like not walking the tree right or something, right? So I do want to go now do some a little bit of due diligence just to make sure that like we actually have some belief in some modicum of understanding that we actually load and raycast these things properly, right? So I'm going to go ahead and take an OD here. Take a note. We're going to OD. We're going to OD this so we get a debug build. And I want to just step through the code a little bit more carefully first, and then I want to add something that looks at the results of the code and tries to validate them a little bit. So when we go ahead and grab the box dump here, and we get 343 boxes, and we set the box count to that, and then we do an allocation. The allocation is going to be 4 times the box count times the lighting boxes, plus however much it took to store just however many were in the file. So this is just giving us a headroom for our tree. We're then going to f-read those in, and then we're going to go into test raycast. The first thing we do is build the spatial partition, and that should... We don't actually want that. Did that actually call debug dump data? Hoping that's just stubbed. Yes, good. Whew. I was like, we don't want it to overwrite our debug data. Not that it would matter, because I guess it is going to overwrite it with the correct data, but that's fine. So we come through here, and we should see ourselves building reasonable bounds, right? So if I look at the occluder bounds here in Remedy, what I should get is I should see these expand as we go through, right? And that is roughly what's happening. By the way, you can't do this in Visual Studio because the watch window is so bad. You can see me just watching these things expand, right? People are always like, oh, you don't need to do that. You can just set a data breakpoint. It's like, that's not why I want a fast watch window. I want it so I can do stuff like this. I don't care about data breakpoints very often. John does, though, and I agree with him. I just don't use them that often. What I want, though, is this. I want to be able to run a routine and watch the numbers change. It's a computer. That's what it does. Anyway, so we can go down here to the root box. And you can see us adding the root box in here. These look valid to me. If I actually look at that root box value, what I should see here is that it has, you know, a valid child count once I run the splitter. So we can get rid of this root lightbox thing. We don't actually need this anymore, but anyway. So hopefully, you know, this child count thing, that's 2 is correct. That's how many there should be. And the first child is that. So that looks reasonable. I don't know what this is about. Calculate ref C. Reference center. What do we use that for? Do we know what this is for? So, oh, that's the colors. Oh, yeah. I forgot. We're still doing average colors for root boxes. I don't think we do that optimization anymore. So we can actually get rid of a lot of that stuff because we're not really doing those anymore. We maybe should, to be completely honest with you. Like, it's possible that we should be doing that, but I don't know that we're gonna, right? Like, I never really came up with a coherent argument of like how we would make distant boxes properly produce good ray tracing results. And the reason for that is we just don't know how much light comes out of an area in a particular direction right now. And we need to come up with some argument for like how we would do that. So anyway, if we go in here to entropy index, what we want to do now is we want to validate that we're actually casting something reasonable. So the ray origin of 0 is just made up. We don't really know where we should be casting. And so that's a little bit of a bug in the sense that we probably would want to figure out a reasonable location. But I don't really know, like we could save that data. Like we could save that in the lighting dump potentially, I suppose. Other than that, I don't really know how we would do it. So if we go through here and also, by the way, that reminds me, wherever that dump is, this should be set to false now because we don't want to dump anymore when we run, right? Anyway, so now that we're in the raycast, we should be able to just take a look, like what's the ray origin, right? Like where is this thing? And I guess I don't know, that's a 4 wide, right? So, you know, it's just zeros. What's the ray direction? There we go. there's probably a better way to look at this, but you know, it's valid, right? And so when we do a raycast now, we should see ourselves walk this tree, right? Like we should walk the tree, pushing boxes on it, like so, right? And off we go. Yeah. So, I mean, I think we're doing a reasonable job with that. You know, I think we're okay. And if we take a look at the results, in theory, at the end of it, we should end up with a thing we can validate to a certain extent, right? And that is the diffuse atlas should have now, the spec atlas should have something in it. Now, the problem is I don't know that there'll be much in it. And the reason for that is because you need some light in order for that to happen. And so in theory, there was some light, but I don't know if it'll necessarily get picked up on one frame. We'll see. But assuming that there is some light in the spec atlas at the end of it, we should be able to verify that that's working. Now, we probably want to put something in the diffuse atlas as well, because otherwise we're not testing the diffuse atlas sampling. It's a little squinky, right? One way we could do that is we could actually just do a capture. Like, we could, when we do our debug dump, we could actually prep a buffer that has everything about the light cast in it, and maybe that's... like, maybe that's actually better, right? Because I'm just worried, like thinking it through, I'm just worried because I feel like we want to actually be able to validate the whole thing to a certain extent. So I do wonder if maybe the right solution here isn't to actually capture the spec atlas, the diffuse atlas at the start, the spec atlas at the end, validate that we get the update we expect. I guess we need them both. Spec atlas and diffuse at start, and then spec atlas at end. I think I might do that. That seems a little bit better. And then we can validate them. So let's try that. So if I actually go to the lighting code, so if we actually jump over to Handmade Hero for a second, and in the Handmade lighting code here, where we're going to do this debug dump data here, this bit, again, like maybe we just dump this as the spec atlas. Sorry, I'm trying to think this through. So in end lighting computation, here I guess I would say, hey there, folks. Maybe this actually happens here. And we dump like multiple things. So in addition to the boxes, we would also dump the atlas. So, right? And then I could just say solution, spec atlas. How does this work again? There's one that gets you the entire size. It's this. So we just say, look, I don't know. Tell me how big this whole thing is. dump it all, right? And at that point, we should have the ability, if we dump the diffuse atlas and the spec atlas, to reproduce the entire thing, right? So we can do, you know, source. Maybe we call these like source. So we do source light boxes, source spec atlas, source diffuse atlas. That's what's like coming into the routine. And then we also dump like at the end. So when everyone's like done, right? We dump those two. So here, you know, we also say like, here's what we got. You know what I'm saying to you? Does that seem reasonable? Because it seems reasonable to me. Like that feels like what you would want to do, because then we actually know what the results should be. Now, there's a little bit more to it than that, because we need to know a couple pieces of information too. So I might go ahead and say that there's like actually like one additional thing that we'll store, which is like a lighting debug dump struct or something. I don't know. And in there, we'd say stuff like, what was the voxel we're actually trying to cast, and what like the sizes of things were, maybe, something like that. Could just dump this piece of junk. I think that would have everything, right? So yeah, maybe we just do that. Maybe we just dump that and call it a day. So that would just take the size of the solution and dump the whole thing. So I don't know, just a off the top of my head situation. If we now run Handmade Hero, in theory we get this back, a complete dump that we can actually validate, which I like better, because as I make changes, I don't want to change the substantive results much. I would accept a little wiggle room, but not much, right? So if I go ahead and say, let's go over to Win32 Handmade, and I run this now, and I go to the data for Handmade debug. In here, we've got this lightboxes.dump. I'm going to delete that. I'm then going to say, let's go to a situation we're going to test. I don't know, maybe one of these bigger rooms out here, like this situation. Right? And then I can go ahead and say, yeah, let's strobe, like capture that. So I'll go over to this variable here, just turn it on, right? And now in theory, we should have captured that data. In theory, you know, who knows? We'll find out. So now if I take a look at in this directory, here we go. We've got a lightbox set. We've got a dump of that struct. We've got spec atlas, diffuse atlas, right? We've got the results versus the source. We don't know if it worked, but we've got it. So let's try now loading this stuff in and running the routine the same way that we are running it in the game. And the only difference will be we're not going to run it threaded, right? So if I go into the lighting code for the game here, and we look at the set of things that has to happen. So what I want to do inside the lighting prof now is just, first I want to make something that loads files, because that's going to be necessary, right? So I want something that loads files, and I want something that will do a test raycast that's the same way that we do the test raycast in the actual game itself. So in here, I more or less want to just call, and I guess to some extent, maybe I literally just want to call the work function. So in here, if we have this compute light propagation work, I think I just kind of want to do that, right? So in here with build spatial partition for lighting, that gets called directly. Where's my end lighting computation? Here it is. So what I want to do is I want to just kind of do this. So I want this to look the same, right? So I want to go through here and say, like, let's do this entire thing has to occur, right? So we want to do that. And the only difference is we're not going to contemplate the multi-threaded case. So we're just going to literally put like this exact thing in here. So we're going to do this. We're going to do all of this, every last bit. And then the only difference is we'll never do that case. So we're just going to run it on a single thread, but otherwise it's exactly the same, right? So this right here should do all of the light propagation that we want. Everything works. The only difference is this lighting queue is nonsense, right? So I think that's okay, because since it doesn't do anything, I should just be able to call it with a 0. So that just means I need to make sure I allocate one of these, or a large enough one of these, on the lighting structure. But other than that, it should be fine. And if I do it that way, then now that means we don't have to do this anymore. What I can do is run it multiple times if I want to, but basically, like, that's the work. I mean, there it is, right? So off we go. This doesn't require any of these things, I don't think, which is a bit of a problem because I'm not sure where they're going to get them from. So if we go to that actual function where we are doing the work, so this is a problem. We have to actually set this up. So we want to do this. Probably. But to be completely honest with you, it doesn't make sense to have that in our system. If we look at why we're getting this, so if you look at this command structure here, if you look at why it has to be there, it's not there for a very good reason. Because the only thing it's actually doing is getting the diffuse atlases out of it. So I would say a better way to do this would be to actually just store those two things in the work structure because they are work related, right? They're things that have to happen for the work to actually take place. So what I would rather do is say, let's go ahead and keep these two things in the system where they should be, which is here. So get rid of that, add this. And then when the work dispatch is happening, we can actually set these up properly. So the diffuse light atlas comes from diffuse atlas. The specular light atlas comes from spec atlas. And now everybody's more properly contained. Like there isn't this load of garbage happening, right? Where we're passing rendering crap down to the lighting for no reason. So that means the only change we would have to make here is we just have to make sure that those get set inside the place where we were previously setting the commands up. So in here, right, this just has to now be diffuse light atlas equals like diffuse atlas. Specular light atlas equals spec atlas, right? And now it should be fine. We shouldn't have any more trouble with that, I don't think. anyone who was previously doing that has to do the new thing now, but that should be fine. These are not addresses of anymore. They're just regular accesses because it's a pointer. And yeah, I think that should be good. What's the problem here? Work hides previous. Yes, that's true. There we go. Okay. Oops. There we go. So now I think we're set up to run like exactly the same code, which I think we want because if I'm going to start doing this performance analysis for real, I might as well do it for real. So what we need to do here is actually load in the atlases because currently we're not actually doing that, and we need to do that. So what I'm going to do is take this piece of code here, which is the thing that actually loads files, and I'm just going to load the files, right? So I want a function here. The function is just going to be called like load entire file, something like this, right? Oops. It's going to take a file name to load. It's going to do exactly the same set of work that this routine was doing before, and it's going to load that file in to memory. Now, the problem is I'm going to want to know the size of the file, probably. Well, actually, I guess I don't even really need that, so maybe we won't bother. You know what we're going to do? We're going to do it this way. Oops. So we've got this thing called struct buffer. I'm going to use it. So instead of returning a void star, I'm going to return a buffer. And what I'm going to do with the buffer is I'm going to put in the size and the pointer, so that way you can get both back. So in here, this is going to be like result.count, right? And then in here, we're going to do an fread into result.data, right? Like that. So now we need to grab, the stuff where we actually open the file. So like this. And we'll print the error message there too. So we'll load that in. We'll get the file out with the ftl. We'll get the size out. We'll have to do our malloc. So result data equals, malloc. So result.count. So see how big the file is. Allocate the data. Copy it into memory like so. And be done with it, right? I also want to do a thing called exercise, where if we want to, you can pad your results out, like so. And that's just if you want headroom at the end of your buffer, because you're going to add more stuff to it or whatever. So load entire file just gets all the information we need there. So now we can actually do a thing where actually we'll just load all of this stuff, right? So we're not going to do this anymore. Like, we're not going to have you specify these files. Sorry. We're just going to load them all in. So we know what they were because we dumped them, right? So we're going to go ahead and grab them in the same way that we were doing them here with the debug dump file. So all of this stuff we're going to grab. So I'm going to go ahead and lemon grab here. I'm going to lemon grab like all of these. Like so. And there's one more, which is like the result set. So we're going to grab those two. All right. So in here, if we then say, what are the files? We've got buffer. We've got like source lighting. That's going to be like load entire file. We've got source light boxes equals load entire file. We've got source spec atlas equals load entire file. source diffuse atlas equals load entire file. Result spec atlas equals load entire file. And we've got result diffuse atlas equals load entire file. So that will load everything we have. And we might as well fclose these, even though it doesn't actually matter because we don't actually care. And we should print out the right file name here, and that seems good. So once we have all of these, can probably do something like this. And just say, hey, like, if there was data in all of them, something like this, then we'll give it a shot. So assuming that we get data in all of them, we'll try running the raycast, otherwise we just won't. And it will already have printed out some kind of an error, presumably, but like, we'll just say, you know, unable to run raycast, test due to missing data. Just give us a clue if that happens. So that's everything. Now we need to use this data in some way that's actually constructed. So the first thing that we can do is we can move this stuff into the actual routine where it actually happens. So what we can do here is say, all right, the global lighting solution actually isn't going to work that way. There isn't going to be a global lighting solution. Instead, when we set all this stuff up here, right, and we go to do our test raycast with whatever it is that we're going to test, right? What we want to do here is say, well, we already have a solution now, so our lighting solution is just going to be like the thing we dumped, right? The struct that we dumped out, that's it. That's the lighting solution we're going to use. So the data from that file is the lighting solution as it was when we dumped it. So that's what we want. Now, if we dumped it at the appropriate place, which I think we did, t-update blend is set to whatever t-update blend was going to be set to. So we don't have to set that. Presumably the series was also whatever the series was supposed to be, because that doesn't get set either. The sampling spheres we're going to have to set to the sampling sphere table because that's an address. We don't have that. The vox cell dim and the invox cell dim, we already know what they are, so we don't need to use those. And that means that the fundamental unit doesn't have to get set. So now we're using our actual data, which is good, right? That's what we actually want to know. And in theory, we probably should have saved this data out, but I think we'll be okay if we just, because we know what it is, so it should be fine. So when we make our light atlases here and we're ready to go, the only problem is the setting the texels. We need to actually set these to the actual texels that they were. But we know what they were because we have them here. So we should be able to then just say, look, the source spec atlas is where you're getting those pixels from, right? And the source diffuse atlas is where you're getting these texels from. And then I think you just run the code. I don't know. I mean, right? So I think if we just clean this up now, that's the thing that we can run and have a little party with our friends. I don't know. So anyway, excuse me. That does everything except the light boxes, which we haven't used yet. Excuse me. So we can assume the exercise is 0 in all cases, except for example, in the case with the light boxes. For the time being, we need the padding there. Now, we don't need very much padding. I don't know how much padding we need. Let's just say we need a massive amount of padding. Who cares? It's just a test app. So that'll allocate way more memory than it needs. Then what we know is the boxes here. So, you know, in this thing where we were going to set up these solution boxes here, we need to actually, like this stuff, right? The box count will be correct, but the box pointer will be wrong. Do you know what I'm saying to you? You know what I'm saying to you, right? The boxes are not, they're, we dumped the struct. All it has is a pointer to boxes. That pointer points to nothing because we just loaded a value out of a file. It's not pointing anything. So we have to redirect it to point to the actual boxes we saved. Which that will do. So I think that should run the test. Now, we probably screwed something up, but at least that's the idea, right? So you get the idea. Let's run it, and we're gonna have to set our source up to be here. Yeah. So now let's go ahead and go in debug mode. Let's debug this, get it working, and then validate the results to see if we can get them to run the right stuff, right? Okay. So in test ratecast, oh yeah, we forgot to allocate the work solutions. That's another thing that we need to do from the lighting because that gets allocated on begin, on init rather. So here's that code. So let's just do solution work. I don't know what this, oops. I don't actually know what that's called. What is that called? It's called works. So I want to do a malloc there to get a lighting work array. So I'm just going to do a malloc size of lighting work. Oops, work times. Oh, and we need an alignment here. Well, we could use an aligned malloc. I don't know. Can we just use push array? Can I just use push array here? You know what? I can't use push array. That's a lie. I can't use push array because we would have to have a platform allocator hooked up. Right? So I guess I'll try an aligned malloc, maybe. Although what I could do here is force it to be aligned by doing something like using align as, right? So in, what's the name of that thing in C++ is crappy nonsense. All right, so align as should work, right? So in theory, we should be able to do something like this, where we just say, look, align as 64. Well, actually, no. I take it back. Since we're running single-threaded, we don't care about false sharing here. So actually, we don't care if this is aligned at all. That doesn't matter. Never mind. We're fine. Yeah, we're fine. We don't care about this. So we just need enough of these to make sense. And if I remember correctly, the calculation for that was we just want this, right? Which we have. We know that number, right? So I think we're okay now. We've got the works. Let's see what else goes on in here. So there we go. We ran the test case. And running the test case, we now, at the end of this, the spec atlas array of texels should be updated, right? So what we want to do is try to validate that. We know that we've got like a source here where we can say whatever the result spec atlas is that we were looking at. And we've also got our result, or I guess we should, it's not source texels. It's it's the thing we want to test against. This is the expected, and this is what we got, right? So this is going to be our texels. So get light atlas texels. So we just want to get the light atlas texels of our spec atlas, right? Like so. So what we can do now is compare these. So I'm just going to ask how many of these there are. So like how many texels there are in the spec atlas. And then I'm just going to loop over them. And so all I'm doing here is reading in all of the texels that we expected to get and all of the ones that we actually did get. And I'm just going to have a total error accumulator, right? So I'm going to say we expected this. Oops, expected. We expected this, we got this. I'm subtracting the two, taking the absolute values, so I can just say this is how much error there was. We look at how much there is, and then we just say, look, that's the total error, right? We can also say total error per texel, and that's just going to be the texel count that we have. So whatever the texel count is, we can divide the total error by the texel count, and that's how much error there is per texel. Now, to get this routine working, we would like to see 0, right? So if I go here and I run lightprof, we'd like to see no error at all, right? And we sort of do. Meaning that's pretty good. It's weird that we saw any at all. Because you would expect this to run the same, but we didn't compile it in release mode, so it's possible that it just like optimized some floating point ops, which would account for that probably. So let's try in release mode. Same deal. So I'm not sure about that. It's incredibly low error to have if there was something off. So the total number of texels is 614,000. And the total error is only 324. Per texel, the error would be invisible. That's below the threshold you can actually see when quantized down to 8-bit. So let's just, for my own sanity, let's just try breaking something here. So let's see what the error would be if I actually just like incorrectly like tracked something. So for example, oh, I know what. So let's suppose we do a different blend. So in here, after we set the solution up, let's set the t-update blend to 1. Forget it. Let's just go nuts, right? Because again, this is the sum. So we're only blending 95% as well. So our error is already dropped synthetically. So I'm just a little worried, right? Oops. Yeah. So this is not right. Like that should be like super error-y. So I made a mistake here. I'm not sure what the mistake I made is, but I made one. Because, I mean, setting this t-update blend to 1 should have given us a drastically different result, right? So what's wrong here? We load everything in. Do our raycast. We set our sources up. We test. We load expected texels out of result spec atlas, which is like not touched, right? We don't do anything with that. We sum the error, and this should make us get like totally hosed, right? So at least that changes the total error. But so something's a little fishy. So let's actually take a look and see if we can figure out what's going on here, because this is a little bit busted. I think it might just be, hey, because that update is so weird. I mean, like, let's say I do this. I should be able to get a pretty crazy error out of this, right? Seems reasonable. Not sure why it's inf. There we go. So, for whatever reason, it looks like that's just t-update blend equals 1 is not enough somehow to make the error as much as I think it should come out to be. Which is a little bit weird. So I'm a little freaked out, but we'll see. We'll keep going. So at least now we have a way of validating, and we're not really in the ballpark here, so something's a little bit up, and I'm not sure exactly what it is. We have our diffuse atlas and our spec atlas set up in theory. I guess one possibility too is that I don't know if we actually dumped those correctly. Like maybe I dumped the wrong things. So this dumps the lighting solution. This dumps the light boxes, as you would expect. That's the spec atlas texels. That's the diffuse atlas texels. Then it runs. Okay, so actually, no, because, okay, so that will, we're now doing exactly that. So we're actually doing the whole thing too, right? We're actually doing this part as well, right? So we're actually doing the part where we fill in everything. So everything is happening. There's nothing we're not doing now. So again, I'm just not sure. I'm not sure what we failed to account for there, or what our actual bug there, like what we're not setting up. We're not doing this. We're not doing this. So that has to happen as well, right? Because the diffuse light maps probably aren't saved here. They might be. Nope, they are. So the diffuse weight maps will be set up too. The light sampling spheres won't be, so we have to make sure those are set up, but everything else would be, right? Everything else would just be stored. There's no other pointers in here that we care about. We restored that one, we create this one, and we update that one, right? Right there. So we're running the exact same code using the exact same settings, and we're getting the wrong results out. Why is it happening? What's the secret? And I don't know. So we dump them down here. Does anything happen to them in between? I don't think there is. I don't see anything. So I don't know. I don't. How much time do I have left here to look at this? I guess I have 8 minutes. It's not very long. So we want this to work more exactly. If there was a very tiny amount of change, I'd maybe say it could be okay due to the difference between the two compiles, perhaps. But I don't really feel comfortable with it the way it is now. I think it's wrong. So I want to find a way to figure out why we're getting differences here between the two pieces of code. Because as far as I know, we're running them the same way, I think. That doesn't do a clear or anything, so that should be fine. And those look both reasonable. Yeah, so I don't really see anything else here that bothers me much. So yeah, that's a puzzler. Why wouldn't we get a similar result here? I don't actually know. What happens inside compute light propagation work? Oops. We look at the work, the solution, the view specified. Okay, we get the entropy out of the work. The entropy in this case is just the random next to the series. That should be set the same in both cases, because obviously entropy has something to do with it. But that should be fine, because we're setting those. This stuff we don't care about, because it, again, came from the thing. So the spec atlas, we do have to have set right, but as far as we know, we did. We just do basic stuff with the tiles here. We do exactly what we expect. We run full cast. We update here. I don't get it. I don't see the problem. So we may have to start on this tomorrow, because I don't see the problem, unless somebody else caught it. Why we shouldn't be able to get similar results out of both of these. So I'm not sure why. We're running this exact code base, as far as I know. So now we're not really doing any test version. We're just running the exact code, pretty much identically, right? And we run each work in series, which I suppose is not exactly the same, but I don't know why there shouldn't be any. Oh. Well, actually, that's weird. What happened to my... Ah, crap. All right, so it looks like somehow I got that accidentally removed. I don't know if that's the only problem, but... What, you know, one thing I might want to do here, I guess, is make this be something you can call to eliminate that source of error, right? I may do that. make this right here be something I can call to eliminate that source of error. Let me see what happens when I run this now. Oh, and we'll get rid of the intentional borking there. So, or did I already do that? Yeah, tupdate's not getting set anymore. Right? Yeah. So unfortunately, still wrong. Right? So that was not sufficient, I guess. Is that... Yeah, so that was not the problem, unfortunately. So what I'd like to do, let me go ahead and remove that source of error though. So I'm going to make something here that's just called like internal void lighting core, right? And what I want to do is I want to try and make it so that this exact thing, like this here, this exact thing here, I want to be its own thing, right? And I'm going to actually put the debug dump for the output right at the end of it. So that way we know that like it's completely self-contained, like so, right? So it'll do exactly this. It will take the lighting solution, the spec atlas, and the diffuse atlas, right? So it'll take those, it'll do this work. I don't know where the lighting queue comes from. It's here. Yeah. And so in here, what we'll do is we'll say, and it takes the lighting queue. If the lighting queue is valid, we'll dispatch it. If it's not, we just do the work, right? So that way we can switch between threaded and non-threaded just by changing the parameter to this function, right? And so in here, when we actually call it, which is right here, we would pass the actual lighting queue so that it'll be multi-threaded. But in here, when we do it, we wouldn't. So instead of test raycast, I'm just going to call internal lighting core. We're going to pass our solution, our spec atlas, and our diffuse atlas, and then we're just going to pass 0, so it won't actually thread, right? And now, at least I know we're doing the same thing, right? So that we can do a capture, we can make it do the right thing, you know what I mean? Everything will make sense. So this part of the code too, I guess that can actually just probably be there. I mean, I don't know this part here where we do the summation. I think this just wants to be, right, like... We'll just return the work count. This is how many units it used, right? And then I think we're okay. So, only thing I need to do now is when we call that, it doesn't have a platform layer, but that's fine. I think we can just do like this. Where is that platform? Where is that stuff? Well, you know what? It's just this value, right? So where is the platform? Gotta update my editor one of these days. Platform API. So now that that's used, I need to have it be somewhere, right? So in theory, oops. In theory, we're good now. There we go. So tomorrow we'll debug that, but then I think we're good to go. Because we got issues, right? We'll go ahead and go to Q&A real quick. Is it still build on? Oh, you just want to know what the build flag is? It's O2 right now. So that's O2. Here's OD. And they had exactly the same result, so it doesn't look like it's particularly related to a floating point precision problem. It's like a bug, right? Capture a single threaded run. I mean, you mean just to see if it's different? Does anyone use, let me just see if there's some kind of weird accidental sharing in there. Because I agree, we should see if maybe it's a sharing issue. So, I mean, you know, this is a sharing issue in the sense that these are not necessarily particularly correctly aligned. I mean, so, but it's not ever overwriting a value. It's just a speed issue potentially, right? But I don't think so. On your US info table early in the stream, you were set to Skylake rather than KB Lake, just in case that's why you were seeing issues. But they're the same, right? They have the same port layout. Like they don't change what ports they are, right? I'm not sure what happens if I check both of them. So there you go. So the port layout between KB Lake and Skylake are the same. If that makes sense. The Ice Lake is a pretty different architecture, I think. So that, if you were on an Ice Lake core, that might matter. You know what I'm saying to you? So, you know, hey, it's issuing on port 9. What the heck is port 9, right? Skylake doesn't even have a port 9, I don't think. So Ice Lake would matter. But Skylake is KB Lake, is Coffee Lake. It's all the same. Ice Lake, which has been a long time coming, it still hasn't really arrived. Ice Lake is still not here. You have to go buy like a low power, like a notebook part to get an Ice Lake core, as far as I know. Like, I don't know that you can get, I don't know that there's like a Core i9 Ice Lake. Maybe there is. Maybe someone who keeps up with that stuff more than I do would know. But Ice Lake is like just in notebook chips now, as far as I know, because Intel's had such a hard time with it. It's their 10 nanometer process, which is a pretty dense process. And it didn't really work. Like the process node was a really bad disaster apparently. So like they can barely fab the chips, is my understanding, and so Ice Lake just didn't materialize. So they have notebook parts that they've been shipping last year, I mean, but they don't have like desktop chips, I don't think. I don't know. I don't think. Maybe there are. I'm not sure. So I don't know if they've ever actually made an Ice Lake desktop chip that you can actually buy, that I can buy. They may have ones that are like very special purpose, but I don't know. So yeah. Let me check that. This is such a great site. Thank you to the folks who built this. I don't know why they built it or what they hoped to gain out of it, just other than being cool, but it's awesome. I mean, it's just great. Have you considered releasing your C course earlier as a beta release, just so many, because many are on quarantine? I mean, if I thought I could release it now, I would. It's not ready yet. So I will release it when it's ready to be released, but you know, it's a course. It's people are trying to learn from it. I'm not going to release something that's not right yet. How long? There's really no way to answer that question because the course is somewhat nonlinear and it's actually very nonlinear, and it depends a lot on what knowledge you're coming to it, right? It's designed to cover everything. And so some people will have to start like at the beginning. Like they don't know what an entry point or a function is, right? But other people who, you know, maybe they've programmed JavaScript for a while or they know Python or something, right? Those people don't need to spend any time at all on that part of the course. Like they know what a function is. They just maybe don't know how they work in C or some of the things about how like functions are actually implemented in hardware or stuff like that. So I think like that's really how long the course is depends on what you need to get out of it. If you just are looking for certain aspects, it is a much shorter course than if you are literally coming to it at zero, which some people might be, right? Volbus, is it bad on x86 to do unaligned pointers? No. So x86 cores for any of the ones that in modern circulation, like Skylake or anything else, they don't have any penalties for unaligned pointers. You can load off of unaligned pointers all day long, and it's fine. However, that said, there are a number of things you have to think about when using unaligned pointers. There are still penalties, for example, for pointers that cross a cache line or that cross a page boundary. There are potential cases where those can hurt you. Page boundary, definitely. So if a pointer crosses a 4096 byte alignment, it's a problem, right? So you have to be aware of that. And the other thing that you have to be aware of is what your minimum target is. So for example, let's suppose that your minimum target is not AVX. So your minimum target is SSE, like 2, 3, or 4. That, if you have to compile code just for SSE2, then there is a real penalty for unaligned pointers, and that's that they can't be memory operands. SSE, for really bad reasons, and it was really bad, I don't know why they did this, they made it so that memory operands fault on unaligned. I don't know why they did it. It was a really, really, really bad decision. They fixed it in AVX. So if you're compiling with AVX as a target and you use vprefix instructions, then you can just have unaligned pointers everywhere. But if you are compiling without AVX enabled, so you're compiling with SSE 2, 3, or 4 compatibility, then you have a problem. Now, that problem may not materialize as any actual harm to your performance. And the reason is because unless you're actually executing 4 instructions per clock, you probably have a free instruction for a memmov in there anyway, right? So it's unlikely that it's actually that big of a deal. Sometimes it can be, though. And you have to have an extra register free. So it depends how much you're pushing the boundaries, right? If you're really pushing the boundaries of the performance of your chip, it could hurt you. If you're not pushing the boundaries, it probably doesn't matter. Unaligned pointers are generally fine. Just be aware of the limitations. Do instructions with memory operands actually use the arithmetic units before the data is ready? No. So an instruction with a memory operand, it becomes multiple UOPs. So the way to read this, so let's take the one that's on the screen right now. So move UPS with a memory operand. This is a store, right? Oh, wait, but that's just a move. So sorry, I need something like we had before. So, okay. So this is something that does an add, right? So this is an add from memory. So it's going to take some register you give it and then a memory destination, and it's going to do an add. The add is going to happen on one port, and the load is going to happen on the other port. So the way that you see this here, this first thing, P01, that's the add port, and this thing here, P23, that's the load port. So what actually happens here is when you do this add PS, first it will, I didn't say the whole thing I wanted to say. This equation, this pseudo equation, the plus means more than 1 micro-op, right? This means number of micro-ops in each term. So this is 1 micro-op issued on port 0 or 1 plus 1 micro-op issued on port 2 or 3, right? So what happens there is when you issue these micro-ops, I believe that's what it is. I don't think that's cycles. I think that's micro-ops, but it could be cycles. That could actually be cycles. So I'll be honest, I take it back. I don't know how they issue, like I don't know if that's 2 cycles on port P5 or 2 micro-ops on port P5. It's probably 2 cycles. So I take that back. It's 1 cycle on port 0 or 1 plus 1 cycle on port 2 or 3 is probably what's actually happening there. So I take that back. Either way, the point is these are 2 separate micro-ops. So when you see the add PS instruction with a memory operand, it actually generates 2 separate things that have to happen. First the load, then the add. The load will first get issued on port 2 or 3. The add will not get issued until the load is done. Does that make sense? So until the load actually comes back, it will never touch port 0 or 1 at all until the load actually comes back. Is the chorus going to be useful for hardcore fans of Handmade Hero? I guess I would say if you've literally watched and and followed along by programming on every episode of Handmade Hero, no, probably not. But if you just kind of watch the series, probably yes. That's what I'd say. I mean, the reason for that is just we do everything on Handmade Hero. I don't know what else we could possibly cover. You know what I mean? I mean, I've gone through so much stuff. Is the course project-based where throughout the course you make X or Y project? Yes, it is. Is there an API to access the performance counters so you don't have to use vTune? Sort of. So there's two things. If you install VTune, I think you can use DLL calls if you have VTune installed to do some performance counter stuff. I'm not sure, but I think you can. Maybe. Don't quote me on that. But the other thing is, event tracing for Windows may provide access to these counters. May. Don't quote me on that either. If what you're asking is the more general question of, is it plausible to say build this into profiling in a game? No, it's a disaster. It has to be running as administrator even to just query them and stuff like this. It's bad. So I don't know of any way to do what you actually want, which is to say, I'm a developer, I'm an adult, give me access to my CPU counters with some expletives thrown in there. I don't know of any way to do that. There is a long route to it, which is, I think there's an open source project that has there's an open source driver that you can compile yourself and install that I think you could then call to get the performance counters. I think. Don't quote me on that, but I think. That would be about the only way to do it. There's no way to just make an executable that does it. You can't do that because it has to run in kernel mode. All right, I'm going to go ahead and wrap it up. Too many windows open. All right. Okay, thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series at home, you can always go to handmadehero.org and you can pre-order the game. It comes with the source code so you can follow along at home. We also have a Kickstarter running right now for our comic. We're doing a print edition of it. If comics are your thing, please go ahead and check that out. There's a banner on every page of the website that you can click to head over there. It'll be running for about 30 days, and it's pretty cool, so check it out. We also have a bunch of videos coming that go along with the Kickstarter, so if you're someone who follows the channel that we do here at Molly Rocket that has all the Handmade Hero videos on it, we will be having a bunch of videos on there. Starting today, there's a time-lapse of a meow drawing going up on there, and then there'll be some other fun stuff that we're doing, probably some additional streams too. So stay tuned for that stuff. I'll be posting about them on my Twitter feed, and they'll also be, if you subscribe to our video channel. I don't actually know these days if you can get notified. Like, if you subscribe to the thing, I know there used to be like a bell you could click on to get notified. I don't know if YouTube seems to consistently be nerfing all that stuff. So I'm not sure what to do other than just say, look, go to the videos tag of our YouTube channel. Here's a trailer for the comic. There'll be more stuff getting posted. In fact, I'm going to post one right after I get off stream now. So check that out. There should be some cool stuff coming on this channel all this month for like the next 30 days. So that's about it. All right. That's it, everyone. See you around. See you tomorrow for the next performance analysis stream. Hopefully we can get the stream validating, and then we can move on to trying to get it faster. That's it for today. And I'll see everyone on the internet. Take it easy, everybody.